So this was fun though, the transistor switch. Um, as you can see here, now I did this actually fairly late at night. I think it was 8 p.m. almost. The circuit is on page 174. So you can see right here, I'll show that is a 5-volt power source connected to the ground. And then it has a 470 ohm resistor. Now it did have a switch, obviously, and you could press it. You see when you have the switch, when it's switched off, there's like very little to nothing going through that lamp. Now you can see it's like just a motoring. See, there's the lamp. It has 181 milliamps going through it. It says in this um, simulator. Now I didn't use the correct ones. Like we're like this is just a default bipolar junction transistor. So the one we actually used was the NGE 3055. They say that it would only be 0.15 amps to 6.3 volts for this lamp. But you can see here, I had to do some weird stuff. So I set it up. You can sort of see, I tried to take a picture of it. But you see, the thing is that the lamp I bought from DigiKey, it didn't come with a holder, and I didn't know I needed a holder till, of course, I went and did the lab. So what I did was first I tried to solder things to the lamp. That didn't work, so I just sort of held the the um the two wires to the lamp, and yeah, then it worked. And you can see it is on. So now there's the next one, effectively the same, is that we wired up a 10 ohm resistor. Let's delete this. So we wired up a 10 ohm resistor. Now we're getting the same things through, same amperage through. Now, one thing to note on my power supply, I actually had to crank up the supplied current for both of these. I think, like I said, needed to crank the amperage up on power supply. Yeah, and that was mostly because it wasn't able to produce, and I was using my power supply, not the Analog Discovery 3 for this, because the Analog Discovery 3 couldn't supply this much. Let's move on to the most fun one, and you'll be able to finally see some Analog Discovery 3 stuff. Let's just read. This is on page 175 of Learning the Art of Electronics. It says, now replace the resistor at the collector with a 10 millihenry inductor. Let's do that. Now, I'm actually doing a few different things here because turns out we're gonna see something cool. I don't know how it will look on the Fall Stat Simulator. In the Analog Discovery 3 channel, it looked really cool. So we had it at 1.5 volts, and then we drove the base with a square wave, and then like this was a battery, a AA battery. There, we drove it with a square wave, and then we put the scope probe here, and yeah, let's see what the Fall Stat Simulator does. And it says max current exceeded. Okay, so for those of you, well, I guess I won't show you the previous one, but yeah. So I made a mistake. I didn't put this kilo ohm here, and I was getting max current exceeded, and it confused me. So I was just going on talking, showing what I got in the Analog Discovery 3. But obviously, the max current was exceeded because that would be like an insane amount of current going into the base there. So now let's do this again. guess it's your first time. But again, we have this is a AA battery right there. Then this is coming from the wave function generator of the Analog Discovery 3. And then this is channel 1 of the Analog Discovery 3. See, it's showing up to 200 and some volts and stuff. So what's happening there is that when this, so like this goes high, and it's shoving that into the base, turns this on. But then this inductor wants to keep the current flowing, so it jacks up the collector voltage. I'll show you what I got in my Analog Discovery 3. So this is channel 1, and you see it's showing minus 10 to 10 volts, and when you turn it off, so there it's on, then it turns off, and it just spikes up because it is trying to keep that current flowing. And then it says it eventually just breaks down that transistor and forces the current through. Now, how they fix that, stop this, is you just add a simple diode. So you see, now you see this is actually nice watching it. So when this goes through, turns on, then it flows, and then when it turns off, the inductor actually pushes the current through this diode instead of going instead of breaking the transistor, which I have that too with the diode. So you got it's off, and you just see 2 volts going down, and then it's on and it's flowing. That's probably 0.2 volts. And then back off, and then it spikes up to 2 volts because it's linked the current flow there. And it just goes back and forth. So yeah, that was the transistor switch, the 5th part of chapter 4's lab. It was quite fun. I hope I didn't sound too incoherent while I was talking about it. And yeah, check out the next lab, which I promise you will either have the Analog Discovery 3, like me doing something with it, or I may also be using the PPK2 from Nordic Semiconductor to analyze current power usage. I'm not sure though, because I haven't actually done chapter 5 yet. So thank you, and check me out next time.